studied architecture and engineering at UT Austin. And then I jumped right into doing some energy modeling and daylight modeling with positive energy. I'm also really passionate about communication. And so I try to make graphics that are visually representative and communicate them clearly verbally as well.
Love it. And I'm Miguel. I've been with Positive Energy for about 8 years, I think it's been now. Before this, in another life, I worked in the tech sector, hated that, not my game. I'm a trained archaeologist. That's actually how I kind of got into buildings, which is a bit of an odd path. But that's what happened. And I also was a was sort of a carpenter's assistant for this union gig for Bill Graham Presents in San Francisco before C3 bought them out, and that was a lot of fun. So if you ever want to chat carpentry specific to stage pieces for names such as Bob Dylan, Train, Dave Matthews Band, we can chat about those at another time. We're super excited to be here tonight. Kate and I have been kind of scheming on how we could talk about a subject that's really important, and that's really making Passive House accessible, like showing people how far they are from Passive House. I think a lot of people, it's not as though the building industry or even the design industry goes into every single day with this, poor ethos and bad work effort. It's a lot of diligence and hard work and exertion, and it's really just a lack of knowledge. We have so much technology, we have so many really powerful minds working on stuff, and it's coalescing that in a way that that really it focuses on the outcome. And that's what I appreciate about Passive House Accelerator, is that it's making resources like this available to folks who want to learn and who want to dig in deeper. So what we're calling this is breaking the norm. And what we're going to focus on is how Positive Energy has engaged in making Passive House possible in markets where it's not normal, where it's an unknown entity and it can feel super scary. So we're going to dive into how we do that. Let me make sure I can actually change slides here. All right, Kate, you want to walk them through the outline?
Sure. So we've got 3 case studies to walk you through, and for each we'll talk about the context, the big question that popped up during our communication with them, our collaboration, and then also talk about what we came up with, what challenges we addressed, and what outcomes we rose.
So we were trying to think of how we could slice this in a way that could be more broadly applicable. Historically, Positive Energy has built its reputation on being building science consultants, but also doing MEP for really high-end homes. We've always had a deep passion for Passive House and have been working really hard to move it into the market here in Texas, as well as other hot, humid climates. But historically, it was just difficult to make that a business model because there wasn't a lot of demand. But we're very, very passionate about the work that we do. And so we saw a clear need for a deep level of MEP coordination and building science consulting for high-end homes. And over time, we've tried to position ourselves so that we can make our services available for projects at different scales and of different budgets. And so a neat way for us to kind of explore how we've done that is to focus on these 3 different projects, 3 different scales, 3 very different budgets, 3 very different programs, all Passive House projects, and all projects where, luckily for us, the owner was super interested in making this possible. So that's kind of key factor number 1 to start working into your mind, is that there are owners who are aware of this stuff, and programs like this really matter in educating owners on what is possible. So the first project that you see on the top left is a house that any of us would live in, right? A normal family wants to build a high performance home. The owner works at a university in Fayetteville, Arkansas, and essentially wanted to try this out as a test case to see if he could become a Passive House builder. So there's a lot of learning to do. Found an architect, but the architect had never done a Passive House, was a little unsure about where it was going to go, how it was going to work. The house you see in the middle a super high-end luxury residence on Lake Austin here in Central Texas, which if you've never been out there, it's lovely, it's beautiful. We do a lot of work out there. And it's actually a fun little factoid. At least last month, I checked, a square foot of real estate on the lake in Austin was as much, if not more expensive than the same square foot of real estate on a Malibu beach property. So there's that. Austin's a totally insane place when it comes to construction right now. But this project was really neat. It was an architect with whom we'd already worked on several projects, was well known for kind of neighborhood appropriate and contextual architecture, does a really wonderful job at not overdoing the architectural expression on the interior and really just bringing you into this beautiful space on the interior. Had never done a passive house, was curious about it. The owner was all in, wanted to really explore every potential aspect of this, had a lot of interest in resiliency, and just wanted to see what was possible. And so that's why we were involved. And then the last one that you see is a hotel, and it's sort of a cross between a hotel and multifamily project on Galveston Island, just southeast of Houston. And it's obviously a very extreme marine climate, a lot of challenges there, and nobody had heard of Passive House on Galveston before. So it was an owner who kind of came from a family that did a lot of development in Houston, and was interested in really seeing, like, he's all in. He wants to do Passive House projects and wants to show what that can feel like, right? And so he's talking about making impacts to big development portfolios out beyond just this project. So yeah, that's sort of the shake of it. Kate, did I leave anything out? Anything you want to add?
One thing that I think is really cool about at least, well, no, I'd say all of these projects is that all of the owners were really interested in sort of making their projects an example for Passive House. They all want to bring other people there and kind of show off the importance of it and what it means to the general public, which is really special.
Absolutely. So that's sort of thread number 2 to start tracking here, is this notion that, or so first of all, the owner is interested, and second of all, these are sort of like hands-on case studies for the local market, and that's a really big deal where Passive House is not normal. So start internalizing that and think about where you interface with Passive House projects in your market. Okay, so how did we help? What did we do? We had to break the typical architectural design process. Typically, when we would engage for MEP services on projects, for example, we're often getting brought in at mid to late DD, frankly. They're on the downhill slope to construction documents. And if we're talking about pulling big levers that have everything to do with architecture and very little to do with the systems that are later specified, that's where Positive Energy wanted to make impact. And so we said, how do we do that? We want to front load our thinking. This is the Mcleaney Curve. If you've ever seen that before, Patrick Mcleaney at HOK came up with this idea. It's sort of Christoph always uses the 4 E's, I think, everyone engaging everything early. That's a nice little catchy phrase that you can think about. But we were trying to process how we could do this, right? How to leverage the expertise that we have at Positive Energy and even bring new value, new services to the market. And Kate has been absolutely instrumental in building that side of our business with these 3 kind of ontological groupings of consulting that we do. And I'm going to let Kate kind of talk through those for you.
So we've divided up performance consulting, which is what we call the early phase of design, into 3 different categories. And this first one is passive. So while the architecture is still relatively malleable, we like to go in and give the architect and their team a gut check to see how well the windows are placed, where the radiation's coming in, if there's going to be too much light in any given space. That also directly usually translates to too much heat in any given space. So it's really helpful for us to help architects understand where those problem points could be before they show their design to a client and the client falls in love with it. Next, we like to talk about mechanical systems. So always our ultimate goal with mechanical systems is to create superior indoor air quality and deliver heating and cooling. But the biggest barrier that we've seen in the engineering design phase is that we don't have a lot of space. And so in the active system portion of our scope, we tend to look at the plans and see where mechanical systems could go, where they make the most sense, and then also point out any areas of potential challenges and concerns for ductwork to pass through. In the resilient systems portions of things, this has to do with something that we are now thinking about on a weekly basis here in Texas summer, which is losing power. Sorry, I don't know if you guys can hear my dog, but she's needing some attention. So we look at solar generation and also with storage capacity and see how well we can meet the needs of a house during a power outage. And sometimes we look at generators as well. It's hard to get away from that in the Texas climate, unfortunately. And then the last thing we tend to look at is rainwater collection. So we'll look at how much rainwater could be collected off the roof, where it would store, that sort of thing, and also space allocation for all of those concepts as well.
Yeah, and just briefly to touch a little bit more on each one of those, when we get into the passive systems analysis, it's one of those situations where often we'll walk into a project where an architecture firm is, we're talking to them about wanting to model their daylighting, model glare, model, daylight autonomy, model for overlit and underlit spaces and shading. And they're like, no, we've got daylight, right? This is what we do. Our instincts are great. And we're like, yeah, we absolutely believe that your instincts are great, and we want to check it, right? It's like there's this, there can often be a magical switch of confidence that's turned on whenever a computer does things. And we have worked with these computers to make sure that they give lots of really good information. And we've had comments from architecture firms after we go through this process, like, wow, I really thought I knew daylighting, and now I feel like I even understand it better, and I'm better equipped to start moving forward through these through this sort of analysis in my own firm, even without positive energy, which is great. Like, we don't need to touch every single project an architecture firm does with the service. We want to get in. It may take a few projects working together, but they can learn a lot, right? With active systems, as Kate said, space is so important. And it's also really helpful, even if we're not going to go through with a full engineering scope, just to have some engineering expertise applied to creating a system concept, right? Not just leaving it to whatever the installers are incentivized to use based on what they can get at their supply house or what they get, a nice kickback for. It really is based on this specific project. It's all about setting up that project for success. And of course, getting feedback from installers is so important. We're not just the kind of firm that's going to hand down an edict and say, good luck. It's not a baton handoff, it's a collaborative process. And so understanding what the market can bear is really important as well when you're thinking about these emerging markets for passive house. And then with resilient, like, this is the second time in 3 days that the public, or that the energy utility in Texas has said, we really need you to conserve power. We don't think we're going to have enough supply today. That's a reality here. It's also, we've had water boil notices, like more in the last, I think, 5 years than we've ever had in the history of Austin, Texas. And water and energy grid relationships are changing across the country. And so we're hearing from projects more and more like, hey, I want to sort this out, whether my goal is resiliency for my own family's sake, kind of that mentality, or whether it's, yeah, this is the right thing to do, or whether it's like, yeah, I mean, this is an investment that I'm going to sell later, and this is what people are going to want. Making sure that there is a plan in place for that is really important. And that's what we get into there. So enough about this. Let's talk about the projects. So Kate, you want to describe this first project for us? Just give us some context about what was going on with it.
Sure. So this is a smaller single family home in Fayetteville. And as we mentioned before, this was the most budget constrained project. This is not a multi-million-dollar house with lots of money to throw around. We were sort of doing what was within the realm of possibility for the owner. And this will absolutely be one of the first passive houses in Arkansas, which is why the owner is really excited about making it an educational component as well. He works closely with the university right now and is interested in bringing some architecture and engineering students in to check it out and see what's going on. The architecture team also didn't have a lot of familiarity with Passive House. And so they brought us in at the earliest level that we do, which is that daylight and energy analysis, to look at how well the house is doing, and if it's sort of in the striking range of what Passive House would need to be.
Yeah, and it's also the case that the owner of this project is one of the sweetest human beings I've ever met. If he's on this call, I don't know if he is, but if he is, hi, it's good to see you. We in our outline, we were kind of framing this with what's the big question, right? And so the big question for this project, he said, well, okay, what is the most economical way and best way I can connect positive energy with my architecture team to understand how close I am to Passive House? I want to get in striking range. And so passive systems analysis, that daylight and thermal comfort modeling, and kind of a broad look at his enclosure strategy was where we landed. And so briefly, you can see just kind of a smattering of some of the graphics from this analysis that we do. And giving feedback at this early phase was so important, and we'll illustrate why. So Kate, why don't you talk a little bit about the window to wall ratio kind of outputs that we learned about this project and what that meant for them?
Sure. So this project decided to go with a Passive House prescriptive method, which meant that they needed a window to wall ratio of less than 18%. And with our analyses, we actually discovered that they were being really conservative and had actually overcorrected for the amount of glazing that they needed. And so they were actually able to add more. And that's a really exciting thing that we get to say. I think this is the only time this has ever happened, that they got more glazing based on our analysis. Yeah.
Yeah, it's pretty fantastic. And just to clarify for everybody, all three of these projects that we're talking about are FIAS projects, not PHI. So as you can just kind of like piggyback on what Kate was describing here, this is a point in time illuminance study and just kind of some snapshots from that. And so what we actually do is when we go through this analysis, we'll build our model, run our scripts, and start finding interesting observations that we want to document for the project team. And that's sort of the feedback round that we want to do with them in Iterate. And so not only will we show them these really great graphics and they get a nice memorandum of this, but we will also fly through the model with them in real time. We can look at the dining room table at Thanksgiving, right? When they're big Thanksgiving family, they want to have everybody over. What is it going to look like? Is it a glary spot? Is it too dark? And you can see like there were some significant underlit spaces here, which if you're even trying to go with the prescriptive route for FIAS, you've got some wiggle room to increase some of that glazing and actually improve the visual comfort without hitting that threshold of negative thermal performance. And that was awesome because it showed the architect, like one of the biggest criticisms that we'll always get when we're talking to somebody new about Passive House is like, well, that's gonna keep me from being able to daylight my spaces the right way. They assume that we're trying to build a Yeti with no windows whatsoever, and it's like, no, you can't. It's artificial to think of architectural design and the daylighting component of that and the thermal performance of the design as mutually exclusive. They are the same thing, and they have a very interesting and unique relationship that needs to be considered and needs to be evaluated quantitatively. And so that's what we were doing in this part of it. And we also took a look at the enclosure strategies that they had, and kind of as they have designed those enclosures versus kind of some benchmarks of Passive House, and then Passive House with some advanced shading strategies. Oh, real quick, before I dive into that, Kate, did you want to say anything about this slide? I'm sorry if I blasted ahead.
No, you're good. Yeah, I'll add one thing, which is that and from my perspective, when we do, as Miguel was talking about, flying around the model, looking at a table on Thanksgiving evening, it really brings the clients and the architects into the work that we're doing, and it gets them really excited about looking at these analyses. It takes an architect from thinking, oh, I know how to do daylighting, like all of my windows are perfect, to, hey, like, here's here's a really big red spot. And you're not seeing a lot of that here. You're seeing the opposite, which is what we worked on to help them. Go ahead.
All right, so back to this. This kind of illustrates the really interesting dynamic at play here, where because Fayetteville's climate is pretty mixed across the seasons, you see in cooling mode, or in the cooling degree days rather, passive house level enclosure with shading does phenomenally well to keep that space incredibly cool, very stable, very comfortable. That HVAC system is just going to have to barely sip energy to keep that space nice and cool, even on super hot days. Whereas if you look at the heating degree days, that shading starts to bounce against them a little bit, right? So it's not allowing some of that passive thermal gain that you get through the windows that they do have. And so helping architects contextualize this through different strategies of external shading, like thinking about how they might make it operable on a seasonal basis and that kind of thing. It's a really fun place to explore. And Kate has done a wonderful job of actually building a lot of architectural precedents that we'll talk through with different firms when we go through this process, so they can see, like, we're not just proposing this abstract thing, we're actually bringing it to design thinking from an aesthetic perspective as well, which matters a lot, right? These people are spending a lot of money to hire an architect to bring this project to life. They want it to look beautiful, they want it to perform beautifully, and we want to help them connect those dots. So this was how we answered the big question for this project, was getting them in striking range. And of course, they already had on their end the CPHC aspect of things figured out. They went through that WUFI model on their own as they started to kind of break away from the prescriptive path to understand what they could play around with a little more. So that was a really special kind of handoff moment for us to say, like, you're in great shape, and you've actually got some wiggle room here. They felt pretty confident and are moving forward with that project.
One more thing I'll add here is that you can tell that the form factor of the building was already set in stone when we did this analysis. And that means that the main things that we worked on were looking at the different envelope upgrades that they could make in the shading. And so that's kind of what we're looking at here. And even though the architecture was pretty much already set in stone, we were still able to make an impact in this way.
Absolutely. And that's a nice segue into this next one, where when we got involved with the project, it was a glimmer in someone's eye. It had barely been conceived of when we got involved. And that was really great, because it was an owner who has plenty of money and wanted to really kind of throw everything but the kitchen sink at it to figure out how they could make this the best house they could be. And the big question for them was, how do we reconcile, the fine architectural detail that the firm that we're working with demands with my robust performance criteria? And that's why they engaged us. We have a lot of experience in both the high performance and high end space, and so it was a natural fit. The owner wasn't, he was not particularly interested in achieving passive house certification. Like, that wasn't a hard and fast criteria. And I think a lot of that in early conversations was driven by the fact that the architecture firm had never done a passive house. And so it wasn't like they were sort of relying on us to navigate this communication with the client about what that means, right? And so when they brought us in, we were literally figuring out block forms with them. Kate, you want to talk a little bit more about this slide and some of what we're looking at?
Sure. So the owner owned the house that was on the lot, and they demoed it, but they wanted to keep the foundation. And so that's what you're seeing here, that the house is the same form factor as the previous house. And the longest facade, the one that we're seeing that's facing like plan southeast on this page, is facing directly south in reality. And that's great to get solar. The architect specifically designed the roof so that it would be really effective at capturing solar energy. However, that also means that a lot of the views were oriented south on that facade. And so this is a study that we did to show the impact of different overhang lengths and how we could get the radiation that we want on the roof without getting it in through those windows.
Absolutely. And what was great is just like in this early part of the design process with the architects, several members of the firm we were working with were just super interested in Passive House and have since gone on to like attend different Passive House conferences, and we have conversations regularly about it. We were also, because we were involved at this early stage, able to get a builder on board who is a fantastic Passive House builder. And, even in Austin, right, we kind of present as this progressive place full of, building science forward, but it's a huge market, and it's a market where there are a lot of builders and a lot of architects who haven't done this before. And so it is very much an emerging market, just like Fayetteville. And so having the confidence instilled, by having a great builder involved, having a consultant like us, doing this analysis early, actually allowed the project team to start thinking through what their baseline might be with confidence, right? Like if we do this, we're pretty confident that a builder can knock this out. And you guys have brought someone into the picture at this point that we think would be a great partner in it. And so, understanding with their aesthetic goals, how do we balance this out through the performance path for FIAS? So that they're in striking range. And that's really what we were playing around with a lot of this passive systems analysis. And as the form got more complete, we started looking at aspects of resiliency. And so as Kate was describing earlier, we're looking at solar, we're looking at batteries, we're looking at rainwater collection, and we're looking at how to make all of that make sense for the specific market that we're in. Okay, you want to talk a little bit about the way that we sized and placed the solar panels on this project?
Sure. So as you can see on the left, we offered the team 3 different options for where to place the solar panels. And the architect was really excited about putting the solar panels on the south-facing roof, but not so much about those other 2 options that we offered. But you can also see on this page that the south-facing solar panels are only offsetting 67% of the amount of energy per year that's being consumed by the house. And so that was an issue that they wanted to address. And so that was another opportunity for us to go back and look at the enclosure and say, okay, well, what are the levers we can pull to make the consumption less, to be more in line with the generation? And also this brings into play the conversation about outage preparedness. So because the house is solar limited, it doesn't make sense for the owner to shelter in place in the entire house. So what we recommended they do instead would be to shelter in place in the garage apartment, and then have some power walls to meet those needs there as well.
Absolutely. And what Kate's pointing at is, we went into a much deeper iterative process, which we can do with firms that have projects that are, higher budget. And it was such an educational experience for the architects and for us to learn how to work with architects in this way, who want kind of soup to nuts consulting. And it actually led to really fantastic outcomes in the engineering sense, because we were really well set up. We also commented on, we did the active systems with these folks as well, and kind of went through the spatial dimension kind of mechanical massing process with them. And it set us up really, really well for fluid engineering. We did mechanical, we did plumbing engineering on this. We did enclosure design, as you can see in the top left. The multicolored image in the middle is an isometric of our mechanical design that we did in Revit. The plan view of it in the top right is actually just the ventilation ducting that you can see. They were very excited about having a really nice ERV, which was a lot of fun. The image in the bottom left is actually it comes from a set that's a bit different than I think what a lot of commercial folks are used to when they think about electrical engineering. We actually provide what's called an electrical master plan. And rather than focusing on the engineering from the panel down to the plug loads, we're actually focusing on the site level infrastructure, from the service entrance, making sure that's sized correctly for the energy needs, through the renewable and backup systems to the panel, sizing it, and then making it such that there are panels or elements of the panel that can serve those islandable facilities that Kate was describing. So when they go to the guest house, right, the garage apartment, if there's another snowpocalypse in Austin, they know exactly how to make sure that that operates. If you haven't heard the term snowpocalypse yet, that is what everybody calls the event of last February here. It was a hellacious time for everyone in Austin, Texas, actually all over Texas. And then in the top left, you see just an enclosure detail. We worked with them a lot about actually getting into materials and specifying what the assemblies would look like. Did I leave anything out, Kate?
No, I think you did great.
Oh, one final note. I'm just looking at the notes here. In our plumbing engineering, it actually got to the point where they were concerned about overheating with hot water lines because the enclosure got to be so robust. So that was I think a really neat kind of educational moment. It made it visceral for the architecture firm. They're like, wow, we're actually having to think about hot water overheating this space, and that's pretty illustrative of how impactful enclosures can be, really thinking about them as batteries for thermal energy and experience. It's pretty wonderful. Okay, moving on. We're gonna talk about the third project. This was the hotel, hospitality / multifamily building in Galveston. Very unfamiliar with Passive House in the Galveston market. If you've never been to Galveston, it's a nice place to go. Texas beaches don't hold a candle to the East Coast, Florida, West Coast, but they're a lot of fun. And if you're careful, you won't get run over by a pickup truck when you go to them. So the context of this, I touched on it a little bit earlier, and Kate, help me remember if I forget something. But the owner was a developer funding this project himself. Was very excited about Passive House, wanted to create this educational opportunity for everyone who stays there, right? So there's actually going to be ways that they sort of guide their guests through the experience of what that space is. And that's really, I think, a lovely way to introduce folks to the Passive House concept and what it feels like to live in a space like that. It had some unique architectural programming. They had multiple spaces that were not necessarily residential or particularly hospitality or commercial. It was sort of a mix of all of them. So we had some navigating to do around code books and figuring out what all that meant. And the project, we got brought in actually after another consultant had already come in and kind of done a similar process to our passive systems analysis and was also doing enclosure consulting. So the big question for them was, okay, with a reasonable budget, maybe not going through this crazy robust engineering process with you guys, because that might break us for such a large footprint. And our enclosure already figured out, what can we be thinking about so that we avoid pitfalls? And what we were able to offer them was our active systems and our resilient systems consulting, which I think made a huge impact on their ability to bring this to a design build outfit actually on the island who could do it without a full engineered design. Did I leave anything off, Kate? Does that sound right?
Sounds good to me.
All right, cool. All right, so why don't you tell us what's going on here? What do we start doing when we're working through an active systems consulting process?
Sure. So what you're looking at on the left is a zoning diagram. And the main difference that we do kind of in active systems consulting versus in design engineering is that we look at the just the zones. We don't really get into a full like room by room load calculation. And the reason for that is that we're trying to get a general idea of how much equipment is needed, where it'll go, that sort of thing. We need to get like a number of ERVs, number of air handler units, but we don't need to fully figure out all of those things that you would in a manual J down the road. So the goal here is to be able to hand off sort of a basis of design to the engineer of record, who in this case was Energy Vanguard.
Yeah, absolutely. And thinking about block loads, it's a way to kind of get quick striking range tonnage data, right? What are we actually looking at here? And then internally at Positive Energy, we're thinking about like, okay, what do we know in terms of equipment lines makes sense for that. How do we actually help them, understand where that would go on the exterior of the building? What do the mechanical closets actually look like? What are the non-brand specific components that they're going to need? And what are the dimensionality of those? And not only just thinking about where the equipment can go, but making sure that there's space for installability, serviceability, this kind of thing. So in a way, through this mechanical programming process, we're describing to the team, what a mechanical core pod could look like. And then they can then build that into their own model and start to figure out where it might make sense. We also comment on distribution. So, my slide didn't change. There we go. We comment on distribution and not necessarily duct sizing for them, but talking about kind of what the max size duct clearance they would need through structure, how to think reasonably about, because often it will run into situations where someone has provided space for mechanicals, but structurally it's impossible to get out of that space. And so how do you actually serve what you need to in the building with ductwork that can't move anywhere? So just kind of thinking through these things when the model is very fluid is a huge way to move the needle towards something that's very installable, that's very buildable. And it's also a really great way for architecture firms to start to internalize how big these systems are. I think a lot of times it's guesswork, and sometimes it's great guesswork. Sometimes it's based on previous experience, but getting, quantitative feedback on these things with engineering oversight without diving into the full financial commitment, especially on like a residential project, for a really robust Revit model and engineering process. They get the data they need, and then this is something that a design build outfit could take off with, or we kind of treat it like here's a schematic level mechanical concept and then hand it off, like Kate mentioned, to an engineer of record to actually go through. And we've done it both ways. It's a lot of fun to kind of play with that both ways. Okay, so resiliency. Kate, let's talk about what their goals were and kind of what we were able to achieve and accomplish with them.
So this project being on Galveston Island is really familiar with hurricanes. And so they wanted to make this location a place of refuge that the guests could feel comfortable at in the event of power outage, water loss, all of those things that come along with a hurricane. And so we tested out a few different options for the solar array, and this is one you're seeing that's 55 kilowatts on the bottom left. And then we also looked at some rainwater collection options, and so we ended up recommending that they go with 2 tanks, and so that's what you're seeing on the right.
Absolutely. And what's really lovely about this concept is that the owner, he's really thinking about the community and contexts in which this is placed, even though it's a hospitality project that's aimed at tourists for the most part. Like he wants food trucks nearby. He wants like this full sumptuous experience that actually adds to the neighborhood that he's building in. That is a source of pride for the community, because it is a place of refuge both for guests and for neighbors in situations where it's called for. And showing that he can really do something that is sustainable and not just another sort of slap together rental house that a family is going to rent for a week at a time, leaving the locals to kind of deal with the fallout, when there is a hurricane or serious storm. So we were very, very impressed with this. He also was so thrilled about kind of the process that we went through together that he used it he was one of the case study speakers at the Humid Climate Conference. And if you're not familiar with the Humid Climate Conference, it was a Trojan horse strategy to convince the good folks in the architecture, engineering, and construction world in Austin, Texas, that Passive House was a totally viable thing. When Katrin came to Austin the first time to present on Passive House, people, and it was actually pre-2015, right? So the climate zone specific standard hadn't been out yet, but was met with so much resistance. And it was just like silly how much resistance was there. And it was not based in fact, it was based on sort of gut reaction to this. Everyone's scared of change, and that's totally understandable. So we looked at like, how do we not dive into the shame and blame game? How do we actually try and show people how close they are, right? It follows the exact same logic. And so what we did is we said, we're going to have a building science conference, because that seemed to be a trendy word that everybody can get behind. And we're talking about the same things. So what we did is we had this building science conference, got great speakers, and then wove in a lot of passive house stuff. And then we did this every 2 years, and we've sold it out every single time. And it's been amazing. Like from when we started it 8 years ago to now, how many people, like how the conversations have changed around passive house in Austin, and more broadly in the hot, humid climates in the United States, and even internationally. So that's been really, really wonderful. It's also been a huge vehicle for FIAS to get a lot of feedback on the heating and cooling targets and such for hot, humid climates, because we're connecting so many different passive house projects with them. And the owner of this project was absolutely in the same vein. He wanted people to know about what he's up to, and actually presented at this conference as a case study for a passive house project that, you know, is not strictly a multifamily, not strictly hospitality. It's sort of this in-between thing, and showing that, you know, weird stuff's also totally doable in the passive house world. And that was really exciting. And so to kind of summarize, you know, we at Positive Energy, we love to dangle carrots. Like that's our big thing. You know, even for projects that have a tremendous window to wall ratio, walking someone through the process of understanding the impacts of that and what the trade-offs are is so much more powerful than just telling them they're wrong, telling them that this isn't something you should do. And it allows people to kind of arrive at those conclusions on their own, and with informed data at the back of the decision-making matrix. And it's part of the reason that I really love working at Positive Energy. I wake up and I feel like great about my day, because it's, even on a tough day, you know, I get to talk to people who are actually trying to move the needle in the right direction. And that's a really, really fun thing to do. It means a lot to me. I don't know what I would do if I didn't work at Positive Energy. I'd probably, I don't know, maybe I'll go be a stage carpenter again in San Francisco, or a monk or something like that. But it's you know, making real this Mcleaney curve, like actually trying to figure out what that looks like from a business sense, was not an easy thing to do, but it's something that we have really stuck it out through. And Kate can attest to this too. Like when we started workshopping these services, we've been doing them for about 3 years now. They have come so far and are so different than they started. And all of it was based on just sort of like, after a project was over, what did we learn from that? How does that impact our contract? How does that impact our process? How did that impact the project outcomes? Like really thinking through all of this. How can we make this more accessible? Does it need to change shape? It's a scary place to be, kind of from that entrepreneurial perspective. Like you don't know how this is going to go. You're sort of throwing spaghetti at the wall and seeing if it's done. But then project after project after project, and seeing this grow is just so encouraging, because it really shows that this has legs. Like this approach makes a lot of sense, and it's not unique to what Positive Energy can do only. Everybody can take this approach, and we want everybody to take this approach. And we look at this as sort of walking in parallel with a lot of other really great thinkers in the market. You know, we do things a way that we do, and we think that that works really well for our particular business model, but we also see plenty of other people doing things in different ways, and that suits your business model, your market. We want to hear from you guys, frankly, hopefully in the Q&A session in a little bit, kind of not only questions that you have, but about what you've seen. We want to hear, those of you in emerging passive house markets, what has been your experience? What's worked well? What hasn't? Spaces like this are so important to share that kind of stuff. And I've been going on for a little bit, so I'm going to let Kate talk.
Yeah, I really like my job too. And I think the coolest thing that I get to see out of a collaboration is when an architect becomes an advocate for high performance and what we're doing. As Miguel mentioned, we don't always get to work on passive house projects. And this one that you're seeing on the screen does have a lot of glass, but we got them to extend their overhangs about 4 feet longer than they would have if they hadn't talked to us. So it's little things like that get me really excited about what we get to do. And yeah, I'll hand it back to Miguel.
I love it. In Kate's describing the ripple effect that happens, right? It's like, this isn't just a project specific lesson that was learned. This becomes part of their firm culture, part of their design philosophy and their understanding of the climate that they're designing for. And we have the unique privilege to work in climate zones all over the country, not just in hot and humid Austin, Texas. So, bringing lessons to bear, thinking about climate specific design strategies is so powerful. And getting to do that, I just feel like the luckiest person in the world. It's really awesome. And it's weird to have come to this from being an archaeologist, digging around in the dirt. But you'd be amazed at the parallels. There's so much we can learn about how societies have really pivoted and changed their practices, based on the artifacts that we leave behind. And ultimately, that's what we're doing with these buildings, is like, how long are they going to last? Is somebody going to find them, long after we're gone? I hope so. If we do it right, maybe we won't be long gone. We'll have built this lovely, sustainable place for everybody to thrive in. And that's, if you want to learn more about us, learn more about how we relate to buildings, we believe that they should be places where people can thrive. And that means everybody engaged in the design and construction process, people living in them, the people that are impacted by them. Look us up on the web. We're everywhere. That's our handle on Twitter and Instagram. Check out our website. And then for those of you that don't know, I am woefully behind on editing episodes, like probably a year behind, and I apologize, but Kate's had me very, very busy trying to bring new work in. We have a podcast, and this is a podcast that Christoph and I started about 7 years ago. And we wanted to get out of the mode of thinking about building science through the lens of just kind of enclosure. And we wanted to look more broadly at the adjacent scientific disciplines that impact the building industry, and then kind of tie them into our understanding. So it's a lot of this kind of synthesis work that doesn't have hard boundaries. We interview a lot of really great experts. When you start listening, you'd be like, how the hell does this apply to building science? And then by the end, you're like, oh, wow, yeah, we should be thinking about that. And it's just such a joy to work on. It's a labor of love. I wish we made money on it, but we don't. So it's one of those things that gets the back burner till I can get to it. And I promise, I will edit episodes very soon. I have some bandwidth, hopefully, on my horizon to do that. And that's all that we have for now. I'm going to drink some water and then kick it back to the host to talk about what happens next.
Perfect. I don't see Kevin, so I'm just going to say thank you, Miguel and Kim. So powerful, those images. They really speak for themselves. You've got enclosure design, shading analysis, solar, batteries, rainwater collection, resiliency plans, 3D MEP, an electrical master plan, hot water overheating analysis, and how to feel secure and stay comfortable during a hurricane. So I think when people ask you what you do, is it easier to tell them what you don't do? And Miguel, I gotta say, I got into architecture from archaeology too.
No kidding.
Wow. It's just you and me, kid.
Wow, that's awesome.
Yeah. So I finally found my people. Thank you for saying that. I had no idea. It's very fun.
We should totally talk preservation work offline. We'll have a beer over Zoom sometime. And
absolutely. So typically this is around the time where we invite people to ask a few questions before the end of the first hour. But I think what we're going to do instead is save all the questions for the after hour, in hopes that Miguel and Kate, you can stay with us, because we're going to hand it to Zach in just a minute. But before we do, I want to share a special announcement with everybody about the last construction tech event of the season. I just threw a link in the chat, and it's basically an invitation to everyone in our community, because we really want to hear from you. We want to hear about the projects you're doing. So if you have a project and you have 4 to 6 slides and a couple of minutes to talk about it, email them to Kim at passivehouseaccelerator.com. Iterate.com and send her a few sentences about the project. It's going to be fun, casual, and we're going to have a really great time before summer break. And we're also going to ask you to share your best tips and tricks so we can compile them into something we can all use all the time, right? We need a best of. We need a best of. Miguel and Kate, thank you again. And everyone at Positive Energy who does the kind of work to break down these complex ideas and analyses into really simple studies of concept, big question, challenges and outcomes, and putting it into those three buckets: passive, active, resilient. It's a great system. And I love to hear that it's always evolving. It was also really great to see the prescriptive path and the performance path and the way you guys were looking at those, because that's still new to a lot of people. And it's still new to a lot of people to really look at their climate and their inboard and outboard insulation and all those percentages right away and have that information for the client to do some really great decision making. So let's dive into our questions with that. And our first question up is from Peter Molinar. Peter, would you like to unmute and ask your question?
Yeah, I was just wondering about the hotel in Galveston, and was it necessary to build on pilings to avoid any flooding, and also hurricane ties? Did you have to use those in the structure, and how is that easy to incorporate in passive house design?
That's a great question. Yeah, they definitely built on pilings. So in 1910, I don't know how many of you were up on Galveston history, but they had a massive hurricane that basically wiped the island out. It was a rough scene, and they built a gigantic seawall to try and prevent that from ever happening again. But regardless, when hurricanes hit the Texas coast, and they do, Galveston deals with a lot of flooding, and so they have some hurricane specific building codes that are in place. Hurricane ties were part of this project, but they also were not in our scope, so we didn't touch too much on like how that interfaced with the enclosure. They had already brought on another really great enclosure consultant and passive house consultant before they engaged with us too. But I imagine it probably was pretty tricky to figure some of that out. That's a fun puzzler. Now you got me wanting to think about this more often. That's a great question. Thank you.
Great presentation. Thank you.
Peter, where are you located, by the way?
Just east of Toronto, Ontario, Canada.
Oh, wonderful. Beautiful country up there.
Excellent. Well, thank you. I hope that answered your question, Peter. I know you had a couple. Did you want to give your follow-up question now?
No, it's okay. We'll go back around.
Perfect. Such a gentleman. All right.
Thank you, Peter.
Thank you so much. And next up is Kim Walton. Kim, are you still with us?
I am. I'm here. Here, I can even start my videos. So I had a few questions. I think the first one was about software, and I think Kate already answered that. So the software that you use for doing this great modeling is it Climate Studio?
It is, yeah. So Climate Studio uses Radiance as its daylighting engine, and then Energy Plus as its energy modeling engine. And so we run it out of Grasshopper, and Rhino is the 3D modeling software that it interfaces with.
Oh, okay. So Rhino and Grasshopper. Okay, that's awesome.
Mm-hmm.
So that leads to another question, and I think I might be asking this for Debbie Coleman too, but just about BIM and about the software that you use. So lately we've been running, when we're trying to collaborate on projects and have a lot of consultants, sharing drawings is starting to become an issue. So tell me about that, because it looks like you do a lot of it.
We do.
Yeah. I think our only saving grace is that we generally will only model a project once or twice. You know, we're not involved throughout the whole process, so we're not doing all that much coordination for the most part. In terms of energy and daylight modeling, we'll usually only do that in the beginning of a project. But we do, prefer to get Revit models. They just have the most information. From there, we can really easily plug them into our daylighting software, and then we will build a simplified box model to do energy modeling.
So do you do certification as well? Do you use the models for certification?
So
We do not. Oh, go ahead.
Oh,
Miguel.
okay.
I was just going to say, like, to kind of piggyback on the Revit comment. So when we move into the engineering phase of a project, when we do those services, we operate out of Revit. And so we're finding more and more, even at the residential scale that we work, more and more structural engineers, more and more architecture firms are working in Revit. Some of them will even use the like Autodesk 360 model sharing platform as well. And it's tremendously powerful for conflict resolution with structure, especially. And we've also started bringing a lot of kind of, it's not normal to have like an electrical design modeled in Revit for a residential project, but we're working on a lot of projects that require that. And so we're making that a more normal process. And we have someone on staff, one of our project managers is also just a total Revit nerd. So he kind of operates as that BIM manager on that side of things. To answer your question about like certification, so we do offer for some projects that want it, we have like FIA specific scopes that we can offer doing kind of feasibility and then pre-cert consulting. We don't get asked for it a whole lot. We get asked a lot more for these performance consulting kind of engagements to understand if they even want to go for Passive House. And so we're not running Wolfie Passive a lot, but we certainly can. And I think I saw Scott on this call actually, Kate.
He's still here.
Yeah, he's he's an architect that works in positive energy and is a total enclosure wizard, I guess is the term, and he's just a wonderful person. So if you're here, Scott, we're gonna butter you up a little bit.
So I had one more question, and that was about the cost. So for single family homes, which is or smaller buildings is what we're working on. This kind of consulting would be something that you might see for bigger projects. So how do your fees, how does this work in terms of costs? Do you have a relationship with the client? Do you bill the client? Does it come in design fees? Is there an understanding at the outset of the project that this is part of the choice that the owners made?
I just dropped a link in the chat to
our
service menu, and you're welcome to
Great.
look at it. I think it breaks it out pretty clearly. We've really tried to modularize this stuff. It's not every project can afford to have like an hourly, endless, unique kind of custom scope for consulting and engineering. We work on a lot of projects like that, and so like especially on our MEP services, we're not inexpensive, and we know that. We've endeavored to make the performance consulting services more affordable for projects, but there's still going to be projects where we're not the right fit, and that's also okay. It's been, from a business perspective, it is challenging to create these kind of new things and try to make them into a package and try to find a sector of the market that will bear it. Like, you have no idea how that's going to go. What we have found is that these services interface very, very well with architecture firms. So often a firms of different size, frankly, too. Obviously, like we work with Lake Flato and Olson Kundig. They're very large firms. They do some of this stuff in-house, and they don't necessarily need to bring us on board for the performance consulting stuff, but they do engage with us for engineering, for example. We work with 1 and 2 people firms as well, who it's a really great resource for them to tap into. We're kind of like an outsourced department for this level of modeling. And by having kind of the way we've built our fee structures out, they know how to budget for this even before they get in touch with us, just based on kind of what their project is going to likely be in terms of square footage and scope. So it's kind of a plug and play model that we've built. Every project's a little bit different with what they want, but we've tried to think broadly around how can we make impacts in a way that's repeatable, reliable, and that brings a lot of value to projects. Sometimes we'll interface with clients. Like Kate can probably tell you a million stories about the best and the worst of the client interactions that we've had on calls. Some folks are like very entertaining and have very specific obsessions that bear very little on the actual outcome of a project, but you're gonna have to do that dance and lead them to, you know, through your it's what is, I guess there's a dynamic on every project where like we're playing educator a little bit, depending on who we're talking to. You kind of have to meet them at that level and really, you know, at Positive Energy, one thing that we focus on internally as well as externally is building a culture of kindness. And that's a really solid way to just make sure that you enjoy what you do for work every day. And it really does translate to better outcomes on projects. People don't feel vitriolic or blamey or, you know, I didn't get what I wanted out of this. They feel like, wow, there's a human on the other end of this call who really cares and is trying a lot. And so when we do interface with clients directly, there tends to be more of the learning curve that we're dealing with, unless that client is an engineer. And then we also have sort of like a, here's how far we're not going to go conversation. So yeah, it looks a little different for every project, but we've tried to make it digestible and palatable for as many projects as we possibly can. That was a long-winded answer.
You guys do a lot, very good work. Thank you so much for that. Thank you.
Oh, thanks for the kind words.
Thank
It's
you.
all Kate, honestly.
Meh.
So it's really interesting, your words for both of you there is because Shannon always says meet them where they are. When I heard your response there, I also heard and take them where they don't think they're able to go. So that's a total deliverable. There's two other things that piqued my interest that had nothing to do with your awesome presentation. And that has to do with the dynamic that happened that while you were presenting, Kate was dropping hyperlinks in the chat when Kim asked that question. That's a crazy skill. And then just now, while answering the question to Kim, we have more links being dropped. And I'm sitting here between the two of you, right, on my screen. And I can't imagine how fun Scott and the other folks must have with the two of you. Amazing. I interrupted the questions because I wanted to share that. And Shannon, back to you.
You know, it's funny, we actually have like on project calls, Kate and I will be like messaging each other, you know, while we're actually talking with someone, a client, and try, because, you know, you want to have like a unified front, you want to talk through these things in a way that makes a lot of sense. And it's such a nice way to like keep good order and keep calls from getting unruly. And it is certainly a skill that you have to cultivate to be like quick fingered and do that sort of thing. It's funny that you noticed it.
I can assure you that during these presentations, the Accelerator crew is texting. We care deeply. It's a great.
Oh, Mark, you just hit mute in the middle, but I think I know where you were going with that. And we fully appreciate that carrot dangling skill you have. And it's really nice to dominate with kindness, right? And in a way where you're leading from behind. It's commendable. I want to just take a moment and ask everyone, raise a glass here. Thank Kate and Miguel for this presentation and showing us how it's done. Cheers.
Y'all are the nicest people
Cheers.
ever.
Well, takes one to know one.
Right?
All right, the next questions up are from Mark Karsten Anderson. Mark, are you still with us? You want to unmute and ask your question?
Sure I am. Thank you. Nice presentation. I was wondering if you could walk through a couple of the color images on the slides. I don't remember exactly which ones. Obviously, it talks about not enough, too much. But as I was looking at the slides, I really didn't kind of quite get what the points of the slides were. I know you're telling me something. I'm not sure exactly what you're telling me.
No
This
problem.
comment came up when it was the envelope, very basic structure.
Okay, like
But I was also hoping you'd go over the one with the internal shading. Is that days, months, whatever?
Okay, cool. I'm gonna rewind here and get back to that for you. Okay.
And I think you need to reshare again.
Yeah, I also need to find where I put that tab. There we go. Oh, I'm using my, I'm just gonna ditch presenter view here, and then that'll simplify all of this for us. So let's see here.
Well, while you're doing that, I just have to say that I've admired your work for a long time, and I wanted to throw another link into the chat because I know you guys did a lot of work with the TOEFL project,
Yeah.
which isn't too far from me. And the link I just popped into the chat is on that project. And I know that Kyle, who did the presentation, shared a lot of the imagery you did for him. And I had seen your work, I think first with Kieran Timberlake and then with Kyle. And I thought, oh, wow,
Cool.
this is really, really cool. They're beautiful images. As I said, they speak for themselves. And I'm glad someone wants you to dive deep on this one because I do too.
Kyle's one of my very good friends. He's a great person, and the TOEFL project is so cool. He actually texted me before we started, told me to break a leg. I don't know if he's on the call or not, but if you're here, Kyle, hello. So is this the slide that you were talking about, Mark?
Yes, it is. Yeah.
Okay.
I think the one following, but this one in particular.
Got it. So what we're looking at here, and Kate can correct course if I go too far off, but what we're looking at is we're looking at thermal energy, and we're looking at that in a very block load sort of way. So we're thinking about zones and how those zones are going to be impacted by an assumed enclosure strategy, right? And that enclosure strategy includes wall thickness, R values, assumed air tightness. Obviously, that's a little further than this analysis gets into, but if we're talking about passive house, we know it's going to be super airtight. And we also look at windows and shading. You know, those are two big levers to pull. And so what you see is on the left we're looking at the distinction is between heating degree days and cooling degree days. And the models on the left in both of those categories show what we modeled as the architecture team had delivered to us, right? So what they told us their enclosure was going to be, kind of their baseline that they were starting at. What we modeled in the middle was the exact same forms, the exact same zones, but with a passive house envelope, right? Kind of showing what that would be. And I don't know if is my video blocking the legend there? There you go. And then, okay, cool. So what we modeled on the right was a passive house enclosure with exterior shading devices. So that's really what we were exploring in this. And it's a quick way to kind of just get, without diving into too much detail about what's going on with the enclosure, you can just kind of get a sense for, okay, are we in a good spot? Are we seeing a lot of red? Are we seeing, some purple? Are we seeing a lot of blue? And then seasonally, right, looking at the heating and cooling degree days as kind of distinct operational modes.
So to walk across it on the upper left, so design envelope. So I would guess that would be ideal because it's facing. I'm in Minnesota, so sun is always good.
Mm-hmm.
Winter, and you're obviously. I used to live in Dallas for a long time, so I understand.
Yeah.
Get what it's like. So, and I understand that red cube on the back is wide open, and so it's just going to get blasted. So that's excessive heat, and so it looks like it's saying, well, your design envelope is going to be too cold in the winter time. You move to the winter, and it's improved. So, is your goal to go to purple?
So the goal is we're looking at zone load. So you can think of the blue as a low thermal load on that particular zone. The red is actually a higher load, meaning it's going to need more active systems to actually condition that space.
For either heating or cooling, red is you're going to need a lot of active systems.
Right, exactly right.
Got it. Okay, thanks. I thought that's where it's going, but I couldn't quite walk through it and kind of see. Yeah, okay.
I'm so glad you'd asked. It's awesome to dive into more detail. Kate, did you have anything else you want to say about this?
No, you did great.
Then I
Thanks.
think the next slide was something similar or related. my memory might not.
Might have been before.
The
This one?
shading one with the overhangs, that one blows my mind. It's just so
I
clear.
already like that. Yeah. That
Yeah.
that makes sense to me. I guess that's the one that was a couple after. And so I guess that's just basically a lighting model effect, because here in Minnesota, I mean, that's the biggest thing I'm concerned about
Mhm.
is, am I going to get too much glare in a room? I'm trying to bring in as much light as I can because I'm in Minnesota,
Right.
and I shade it in the summertime, but the sun is very high here, but I don't want to bomb rooms with too much light and get glare or get overheating. And so I think it was like 4 or 5 slides later, that was the one that I was interested in.
Probably would have been this one.
Yeah.
Yeah.
Yeah, because it looks like so obviously the rust color, those are the areas that are getting bombed.
Right, yeah.
With excessive, and you can really see what's going to be gloomy.
Right, exactly. Yeah, we're using lux as the metric here, which is a measurement of light and its reflectivity on surfaces. And so that's essentially, we try to represent it on this color spectrum in a way that shows you like where things are performing in a way that maybe aren't ideal. And so what are the architectural strategies that you can employ to actually try and improve that, right? And so like we were discussing earlier, this one actually was underlit in a lot of scenarios.
Right.
And it's very difficult to find perfect daylight in even the best house. Like, just you have constraints that you run into that are going to make it challenging to do it perfectly. But it's a seasonal thing, right? It does change, as you're describing. And so just understanding what the impacts are can go a long way. And it may trigger some creativity between our team and the architecture team about what might work to try and mitigate some of that.
Okay. And then do you do modeling on the shading shapes if they're, exterior shapes mounted on the envelope to cut glare in an area?
Yeah, Kate, why don't you talk a little bit, I bet they'll find this interesting, both about kind of the way we treat trees and the way that we treat exterior shading when we do models.
Yeah, so I'm actually probably this next week going to do a model where I look at different types of shades. I'm going to look at horizontal shades and then vertical shades and then angle them and see if that makes a difference. So we do all of that good stuff. And then where trees come into play as well is that we will generally model some sort of circle or, the shape of a tree. If it's an aspen tree, we'll do something a little bit taller, more like a cylinder, that kind of thing. And then we have a script in Grasshopper that will like randomly triangulate the surface and reduce it to a point where it matches an opacity of a real life tree. And so that the goal there is that generally when we model trees and daylighting, we're overestimating the amount of shade that they're bringing into the house. So by reducing some of that solid nature of any kind of shape, we're mimicking what leaves are doing. And so we can see if there's more light coming into that space.
Okay, thank you. And so my last one's Minneapolis, St. Paul, hot, humid summers, cold, dry winters. How would you see? I mean, it's very different from the work we do. Would you feel comfortable working in this kind of a climate?
Yeah, we're about to
things freezing, and bringing as much light and sun in as we can.
We're
Don't cook them,
We're about to start a project outside of Ely, and I've been up there many times.
Yeah, that's cold.
Yeah. Oh yeah, we're unafraid of cold. We work in Jackson Hole where ASHRAE design temps are like -25, but I think that the local code requires -30 as the design temp. So if we can handle that, we can handle just about anywhere. And we've done stuff all over the country. So we really do dig into the actual climate data. We leverage a lot of the wisdom that project teams bring to bear as well, just about their experience with different systems, different strategies that have worked. And then we cross-check that with data, right? We're leveraging science, trying to apply it to these projects in a way that is actionable. And so, yeah, I'm unafraid of Minnesota.
For
I like
climate,
Minnesota.
yes, your services can be very climate specific.
They have to be.
Yeah,
Absolutely.
right. Of course they are, but yeah, in a very, very different climate. Yeah.
Yep.
Yeah.
From my perspective, it would just require a bit more research, as opposed to saying, oh, this window's getting a lot of direct solar radiation, I need to shade it. I would say, well, what sort of benefit does it have in the winter versus in the summer? And sort of bring another level into that analysis.
Right, which I kind of gut right now, or imagine in my mind, but obviously, somebody posted earlier, modeling is great, rather than just perceiving this is what I think is going to happen. Okay, thank you for your time. Very nice presentation. I appreciate it.
Thanks for the great questions, Mark.
Thanks, Mark.
Yeah, Mark, way to go. Way to wrap it up with a big one too. Thank you. Curious, now that you've mentioned shading and shades, how you deal with automated shading and whether there are user overrides because clients want them. You don't want to be sitting there looking at the view at your party and down come the shades because the solar gain is increasing, right? Can you speak to any experiences you have with those, modeling them and then understanding the override piece?
Yeah, that's a good question, and frankly, something that we haven't touched a whole lot in our kind of our early concept modeling. A lot of times we'll use a lead schedule. So if there is a certain amount of radiation coming through the window, the shades will automatically activate. But the other side of things is that having a home automation system to activate shades actually uses a lot more energy than it saves. So it is more helpful to have a human being manually operate those shades. So that's generally our recommendation.
Yeah, I'm interested to hear that. And I'm working on a project right now where the windows are the boss. We've got so much glazing. It looks a lot like that last project you shared. So not exactly an optimal wall to window ratio, but automated shades are going to get us there. And I think we chatted about this before, where some projects can, buy their way out of a lot of problems. So it's a great benefit to have that option if it's available. But the ability to model it appropriately is kind of new territory for all of us, right? So thank you. And I'm gonna keep in touch with you, as I'm sure that will be next.
You just reminded me of something really great, Shannon, and that's the idea that, and I say this as somebody who we sell this, right? But all models are wrong. Some models are useful. And so what we want to do is provide useful feedback. And usually we're trying to look for the big levers to pull. We're not trying to get into the weeds, we could get into what kind of deciduous tree this is, and how do you actually it's not the diminishing return on that strategy is probably going to show its head pretty quick. And so what we try to do is where are the big problem points, and just focus on those. And it's amazing how impactful they can be. They can completely turn a project around from something that was maybe on a path to not being high performing at all, to something that's oh wow, we're really not that far from passive house if we want to go all the way.
Yeah. And to use the passive levers first is really where it's at, right? So I love the graphic, other way, this one that you've got right behind your head here, where you've got those solar angles, just making it so clear how the seasons are changing what your energy loads are doing. All right, next question. Who is next? Debbie Coleman, you've been so patient. Are you still with us?
I am still here, Shannon. Can you hear me okay?
Yes, welcome.
Okay, welcome. Thank you, and hello, everybody, and thank you, Kate and Miguel. I got very excited when I saw there was an MEP subject with the passive house or any kind of residential design, because I just feel like there's just not enough MEP firms in the residential industry that are knowledgeable and doing a good job, and like you said, providing value. So my question, if I think back, I think it was the second house, maybe the larger of the two. I want to say it might have had a 20 kW PV system on it, which my first impression was that seemed rather large. So I guess a general question would be, what are you finding in the high performance homes that you're working on? What percentage of the overall load is, say, for the mechanical, for the HVAC, and I guess we could throw in the water heating with that too.
Yeah, this one had a huge system. The owner had some unique kind of power goals and some, obviously you can see in this image here, there's a pool. Whenever you see a lot of energy use, that's the first place I look, is there a pool? Because there's going to be a lot that goes into that. And so trying to offset the operational use of that pool was one of the big goals in having a large array. Islandability was obviously sort of the strategy with regard to, what is the kind of core need for energy in an outage, right? Like thinking about resiliency through that lens of, can I weather, disruptions to the energy and water grids? And that was the strategy to go to the garage apartment. So it depends on the project, really what their goals are and kind of what the scale of the project is. Because we've worked on projects that just want, I want a little backup in case something goes wrong and I can run a heater, a nice heat pump, and have clean water. Like that's a very reasonable and often well in striking range financial goal for most projects, if that have a little bit of budget. And then we have other owners, like we just worked on this one project north of Austin, like pretty high performance goals. They didn't go to Passive House, but they did a lot. The owner was just obsessed with power walls and has more power walls than he will ever need, ever know what to do with. It's the kind of project where the very large chicken coop is larger and more expensive per square foot than any house that I will ever dream of living in. And the chicken coop also had its own power walls. So to me, it's like one of the, we work on kind of everything in between those two bookends. And it's a lot of fun to dive into that space. So the person on staff that leads those efforts is our lead engineer, Charles Upshaw. He's a brilliant guy. He knows a lot about thermodynamics, a lot about water. His PhD, I believe, was on using rainwater capture to actually as a thermal battery. So looking at thermal storage and rainwater storage applications, which is really cool. Not super practical in the market yet, but we're working on it. But he also has another consulting firm that actually consults with utilities, right, on thinking through their kind of grid hardening sustainability strategies, how to decarbonize their operations. And so he just has this wealth of knowledge about kind of broad knowledge about water systems and energy systems that we try to bring to these projects and meet the team where they are, and not try to be this, you are doing this, and this is the only thing that we do. We really do try to have a sympathetic understanding that needs are different, the markets are different, that the modules available are different. And then we do have experience and do offer, it's more of a custom scope and typically at larger scale, but full solar and backup system designs. We actually worked on this tremendous summer camp here in the Austin area called the Camp at Shield Ranch. And it's entirely off-grid, both water and energy systems. It's the first public utility in the state of Texas that's run on rainwater, which, as you can imagine, is a regulatory nightmare. And it's also got the entire thing is backed up, with batteries and solar array and fully functional that way. And we got to go tour it. The Committee on the Environment here at the AIA Austin did a tour of this place. They're wrapping up construction. They're kind of getting towards the end at this point and starting to commission everything. And it was just amazing to see all of this hard work from years and years of these design iterations come to life in such a powerful statement too. It's like, it's possible to be completely off grid. Obviously, a summer camp's different than a house, is different from a hotel. So there's so much that you have to kind of cut through to try and understand what's an applicable and reasonable system. But that's the kind of expertise that we try to bring to bear through that resilient systems service. And it's kind of cool. So Christoph, just recently, for those of you who are Matt Reisinger viewers, I can't keep up with, he's got so many videos, it's insane. But Christoph's done a lot of videos with him. I've done videos with him in the past, but Christoph has been really excited about getting the message out about this approach and these performance consulting services, and just recently did one, and we had tremendously great feedback about it. And we're planning on a round 2 with him, where we dive into more of the energy and water systems specifically. And so that's going to be really fun and a lot of I think exciting kind of new territory for his viewership. So we're pretty thrilled about that. Be on the lookout for it.
Does that answer your question?
I hope so. I have no idea. I just start talking and I don't know.
I love it, because I have a million questions now, and I want to make sure that you know the last one got answered, so I can just dive into what's next. But
Shannon, I want to go to that summer camp. You know, that summer camp. Yeah,
I do too.
It's pretty rad,
Kevin.
Maybe we'll teach the young kids how to be teenage passive house tradespersons like Dylan.
I love it.
Absolutely. You know, I'm really sad that there's a mechanical engineer that's usually on these calls who actually wrote an article about doing water battery. And it's tough where we are because we freeze. So if it's not a summer camp and you're going to live there in the winter, that gets to be an issue if you can't keep it in the basement, and getting some manageable sized cisterns together, right?
Right. Yep.
But I love that you're pushing in that direction, because we all totally understand what coolants do to our energy goals when they leak. They just wipe out all the good work that we do. It's what a lot of friends of mine are starting to call invisible carbon, right? It's the carbon that we're not accounting for, that's just killing us sometimes when mistakes get made or when things fail. And it would be wonderful if we could use a battery that took 2 of those elements out in one foul swoop, right? And what's more recyclable than water?
We've been pushing a lot of our projects to go hydronic. We signed on to the MEP 2040 commitment, which is the Carbon Leadership Forum's program for MEP firms. And we actually just had like a really great kind of office-wide brainstorming. We have these probably once a month, Kate, where we do the big questions lunch.
Yeah, once a month sounds right.
It feels right. I never know. Time isn't, after the pandemic started, I don't even, like, my hippocampus is broken and it'll never come back. But so these big lunch sessions, essentially it's like, you know, we're always working on projects, and we're like in a, you know, some kind of business development meeting, and it's hard to like think about big things that can expand your horizons, that can cause you to think about your work differently, that can really spur inspiration and innovation, and make you a more well-rounded individual. And so once a month, we try to have these big questions lunches where, it's just the internal team at Positive Energy. We buy lunch for everybody, and then we just set a topic, and there's no rules. It's just like, let's see where this goes and see what kind of conversation we have. And they're always so fun. And we did one recently on like what it meant, because the MEP 2040 commitment is relatively new. And they're still trying to figure out like what it means and how to engage with MEP firms. But they have a lot of really great firms that have signed up for it. And so we're trying to understand, like, what does Positive Energy want to engage? Like, how do we want to engage with it? And so we talked through a lot of that. And one of the big things is like, talking about electrification is huge. In the passive house community, that's very easy to do because it's already in that direction. Lots of projects we work on are not quite there yet. And so it's a big deal to, say to a billionaire owner, for example, we want you to ditch your range, your gas range. Like, whoa, talk about slamming the door shut on somebody's brain. That is a very, very challenging space to be. Or in cold weather markets, even where air source heat pumps or ground source heat pumps could be totally viable, like, we do boilers here. What are you talking about, right? And so the same approach that we take to bringing passive house to emerging markets, we're also just trying to bring up the baseline of understanding about what houses can be and how systems can operate in the projects that we work on. And frankly, a lot of it is like, okay, sure, there's the design conversation, and like when we get involved is super important. But connecting with the implementation team, like who's the builder, who's the installer, what do they know how to do, and what can they knock out of the park, and what kind of risk are they willing to take? It's a political dance, frankly. Like it is not an easy seat to hold, but it is one that carries tremendous power, and it's one that we take very seriously because there is role power in being an architect. There's role power in being a builder. There's role power in someone saying, I'm willing to spend, X million dollars on this home. We want that. We want to honor that. We don't want to build movie sets. We want to build things that last and that do right by everyone, including the folks that are totally downstream in the unseen impacts of those buildings as well.
Yeah. We've all seen the scales of justice, right? Except you're a fulcrum and you've got like 20,
right.
20 that are all balancing. It's like a cauldron, a beautiful cauldron going on there, and you got to keep it all in play. That's a super great message. Who is next? Oh, Peter Molinar, you've been waiting to come back around with your second question. Come on out.
Just wondering if there were any time to tap hot water calculations done for any of these projects. Is that something you do?
Yep. For the second house, when we did a full plumbing engineering design, so we do that calc. And are you familiar with Gary Klein's work out of California? Yeah, so Gary is a huge mentor. He's a friend. We've eaten Ethiopian food together in many cities. Great guy. And he's also made me water, right? I have to be the water. So we leverage his kind of design philosophy around plumbing engineering. And we also have phenomenal engineers on our team with tremendous experience across different typologies. And so, just bringing kind of the specificity of specification and making sure that it's a buildable reality. It's really challenging. And frankly, like, in the residential context, having the entity that's designing the mechanical system also design the plumbing system can avoid a lot of conflict that happens in the field. Because I've walked into countless projects, to do framing alignments for ducts and been like, well, they had the plumber out first. We got to move all of that. And nobody wants to do that. So just having it aligned in design is pretty awesome. And then that's such a huge selling point to a high demand owner, right? To say like, you got to wait 8 seconds to get hot water here. And to do that without just totally botching the energy profile of it is not a trivial task. So we want to do that the right way.
Just threw those links into the chat, and thank you for that question.
Cool.
Peter.
Yep.
And let's see.
Just wondering if you find the schematic drawing useful for preventing clash between systems of electrical or plumbing, and do you specify where the ducting or piping or wiring should go as opposed to leaving it to the installer contractor? I've seen that go real wrong.
Absolutely. Yeah, I'm going to open up a link here. So we work in Revit, which allows us to do, if the structural engineer and the architect are also working in Revit, we can do like automatic clash detection, which is pretty great. The level of detail that we get into, which I'm going to share my screen again with you. We go, I think it's like LOD 300 or so, which is pretty robust for residential. Oh, that's not the tab that I wanted. Sorry about that, y'all. Can you see this?
Yep.
Okay, so on our mechanical plan sets, for example, we actually will host our Revit model on this Autodesk viewer, and we'll tie it to a QR code that the installer, like we'll put it on our construction document set. So the installer can actually like open this up on their iPad, and they can dive into exactly how that mechanical room is supposed to look. They can pan and tilt and do all the things that they need to figure out exactly what our design intent was. Because even on really well-drawn plans, if there's a mess of ductwork that was kind of constrained by architecture, it can be challenging, even with good, documentation and direction, to know like what direction does that pipe go, up or down. I don't know. This takes out the ambiguity, and just, you know, thinking in 3D is not a skill that everybody has, but it's one that is totally learnable. And this is how I think that people can start to learn, is really looking at a plan in section and plan view, and then looking at it in 3D and understanding it from whatever isometric angle they need to. It's a powerful tool, and it's one that we've got such good feedback from installers on. They love it. They're like, please keep doing this. This is excellent. Autodesk makes it a little challenging for us. We have there's limits to the time frame that you can host on these links, and so we have to like go back and refresh our projects a lot. But you know, we're sorting that out, and we've already got 1,000 complaints into Autodesk about it too. So we'll see if they respond.
You can just export to the viewer though, right? And send it to them, send it to your client, and they can hang on to it. But then it doesn't update. You have to send it again. Yeah.
Well, we found, well, not every installer has like an Autodesk viewer on hand. And so just having it like web hosted, that opens in Safari on their iPad, right? And so it's super easy.
Oh, that's so true. I didn't even think about that, of course. And when you're talking about the guys in the field, they need to have it right then, right there. Yep. Now, that leads me to the question I had, which is, how often do you get pulled into clash detection because you are kind of putting together all these 3D models? Do you ever get pulled into that, or do you leave that to the architect or another member of the team?
Yeah, so for performance consulting, and Kate, feel free to jump in. I feel like I'm dominating the conversation, but performance consulting, we're well before clash detection is needed at that point. We're really kind of looking at performance at this very high level. When we get to like the architectural design development phase, and we're starting to dig into the engineering, that's where the clash detection happens. That's usually, we're getting brought into projects for engineering at about the same time that the structural engineers being brought onto the project as well. So often we'll even have like a pre-coordination meeting. And then of course we do clash detection with mechanicals. And if we're designing plumbing and electric, then those are happening as well.
Something we can do earlier on though, that I find really cool is we, in active systems, we do sort of make the recommendations that will prevent clashes from occurring later on, like not putting a mechanical room below a staircase, or like on the wrong side of a staircase, things like that. Or if there's a major wall terminating, we want to make sure that we're able to get ductwork through it. We'll point things like that out to the architect in the concept phase, so that hopefully it's on their radar way before clash detection occurs.
Yeah, when you ask for 20 inches clear, like that's a big ask, but when it's really early in the project is the right time to ask it, because nobody wants to hear that when they've already got their DD model put together. It's like, oh no, what are we going to have to go back and change that the owner's already fallen in love with?
Yeah, nobody wants to resize piping late in the game.
I think it's great that you guys are actually designing fully ducted returns and showing where they should go in the bottoms of the units, and just that alone helps the design team know, like, and the installer, like, this is an optimum design system. Like, we're not going to be doing silly things like plenum returns that always grind my gears. But that active design process you guys have, it makes a world of difference, because it lays it out. It makes it a picture that the HVAC artist has to recreate, and it's great.
Yeah, absolutely. Yeah, and so like, you know, the difference in terms of scope, right? The active systems is sort of this pre-engineering mechanical massing system concept layout. It's really helpful for just like, we needed to understand what direction we're going. And then the projects that opt for full mechanical engineering, I mean, it's robust. We're getting into we go from load calcs, equipment sizing, selection, you know, down to the level of really thinking through like what lengths of duct stick can they get, and making sure that that's kind of reflected in the drawings. Every unit's going to be specified. We get down to the level of diffuser selection and placement. And so for a lot of the high-end projects, you know, that's a big deal. They're thinking about symmetry. They're thinking about hiding things, making sure that a mud-in slot diffuser is like perfectly executed is not a trivial thing. Having a really good plan in place to make sure that that's not compromised by a few inches that's like forever annoying to this person that just paid millions of dollars for a house is a big deal. And those design principles, you know, reflect, they play straight into the lower budget but high performance focused projects that we work on as well. Like, you know, we want this expertise to be available. It's a lot of work, which is why we're expensive, and like there's just not a huge market for this. And we're frankly like, it's easy to be a profitable company. It's difficult to be a profitable and super ethical company. And so like taking care of our people, building that culture of kindness from the perspective of benefits and salaries and, you know, healthcare, that sort of thing is no small feat. And none of us have yachts. So we are in the trenches doing the work, and we love it. It's pushed us towards the high end of the market, and that's a reality that we've just had to deal with, right?
Miguel, though, you know what else is expensive? Change orders.
Yeah, they are.
Most of these houses that we're designing, even a lot of the high-end ones, they aren't designing the mechanical room. They aren't letting the homeowner know there's going to be a diffuser behind your master bed, you know, or your main bedroom bed. And that's disappointing stuff that, if changed in the field, is a real pain, or if not figured out and then sequenced and coordinated in the field, I imagine that causes some delays and some additional costs. So bravo, really fantastic. I have another question for you if I didn't stop you from finishing your thought there.
No, go ahead.
Okay, and I know it is 8:47, so we're gonna probably do another 13 minutes of this if you can hang in there. The last question I have, though, was from Mary Angela Hahn, who couldn't ask it herself, and she asked, please discuss warm roof versus cold roof. What is the difference in the climate zones that are likely best suited for each example, such as Northern Utah? Thank you.
Northern Utah. So when I hear cold roof or hot roof, I usually assume that person's not from the South, because that terminology never gets used here. It is very common in our climate zone, which is 2A, which is very hot, very humid, to see fully conditioned attics, right? Which is the hot roof. Unfortunately, I also walk around and see a lot of ventilated attics that have just been done horribly here, with mechanical distribution and equipment in the unconditioned space, which is just not what you want to do. So like, however you want to strategize your roof, of course, it depends on climate zone, right? Like ventilated roofs or ventilated attics were designed to prevent snow dams and ice dams. We never run into those problems in Austin, Texas, and probably won't. So it's one of those things where like there are building practices that have emerged from some of the original building science textbooks that were issued, and they have sort of become ubiquitous. And there's a lot of like, I think folks who are interested in enclosure, who want to get into the details and like figure it out. And there's so many resources online that you can leverage for this. Thinking through your general strategy for a house, it probably is going to be aligned with like what people know how to build there and what they're willing to do, and how you're planning on conditioning that space. Because you can absolutely have a ventilated attic that works really well, but it's going to impact where you're placing the mechanical equipment and distribution. It's also going to impact, downstream of that, it's going to impact every connection that you have, right? If your wall to roof, and then, what does that assembly do to your foundation connection, and what is your foundation? So it's like this interlocking, circular dependency kind of situation. I would recommend hiring a professional to get into specifics rather than kind of like think in broad strokes about what should I do. There's so many free resources online that I encourage you to look up. Like Building Science Corporation's got a tremendous volume of digests and details and articles that you can read. Like one of my favorite resources is the Hammer in Hand Construction Best Practices Manual. It's so good. Skylar, who also consults a lot for Positive Energy internally, I think was one of the original authors of that. And he's also on the VS Technical Committee. He's based out of Boise, phenomenal human. And then, obviously like Passive House Accelerator has tons of resources that you can avail yourself of. And then there's like, there's so many enclosure consultants. So if you want to dive into details on that, I think it's easy to do that and easy to find somebody who can help. Hopefully that wasn't too evasive. I just don't, I mean, it's such a rabbit hole that we could dive down, and I don't want to do that because we've covered so much ground, and that's like a whole ontological layer deeper that I'm not ready to get into tonight. I haven't had dinner yet, so, you know.
I'm with you. All right. I did get another question to ask on behalf of Mike Lind. It's pretty technical, so feel free to punt if it's a bridge too far, given that it's 8:51. But when calculating the U value of a wall or a roof with exterior foil-faced ISO, do you take into account the vent channel where the top deck and cladding has foil facing into the channel? I know the furring ends up at least less than R2, but what about the open vent area? As I said, it's deep dive.
Yeah.
I know, that's a tough one, right?
No, I mean, you could probably, that's such a good question. And also one that's like, that's so many hours to figure that out. Within.
And you haven't had dinner yet. Okay, I think I'm gonna to
You
Kate.
can always say it
I'm gonna let you
depends.
think about it and pivot to Kate and say, Kate, we know what Miguel did before he did this, but how did you get into this? What's your story? Where were you before you became a positive energy force?
Sure. This kind of gets into the mentorship question that I've been preparing in my head for a while as well, which is that I was at an architecture internship. I don't know if any of you have had the opportunity to go through architecture school, but it's the worst. And so I went to this architecture internship and was this was like my last ditch effort. I was like, if this is really bad, I'm just going to say goodbye. And at the architecture internship, I got connected with someone who was doing modeling in Ladybug and what's the other one? Honeybee. And I just got really excited. I'm such a visual person, and I thought that the tools could communicate these really complex concepts in a really compelling way. And so that's sort of what launched me into looking at performance consulting. And then I had a teacher, Professor Nagy at UT Austin, who said that I should look into positive energy. And I did. And I think I emailed Miguel like 2 weeks before the pandemic started. So you know what happened after that? They punted me for a while, and then came in hot with the project in May, and I started working like the next day, pretty much.
Excellent.
Haven't stopped since.
I love it. And how long does it take you to iterate on some of the images that you produce, like for every project? You know, I'm sure you've got a wheelhouse, a kit of parts, a toolkit that you go to every time just to get your bearings with a project. And you're producing a lot of images right at once, and you're consolidating them for the client to look at. How quick software that you're using? How fast is that process for you?
I'd say that modeling can take, I'd say around 10 hours. And it really is a kit of parts, because we want to see the daylight, but also next to the radiation. And then, you know, what happens if I extend that overhang another 2 feet? All the questions like that, answering them kind of helps tell the story of what's going on and what we have the power to change versus what needs to just be a smaller window, which is not an answer that a lot of folks want to hear.
Right, and that's I imagine you keep some really good graphics in your back pocket when you feel like you're convincing someone, and then you can say, well, now look at this. You know, architects do that all the time. I'm sure you were trained to do that before you left us for greener pastures.
Yeah, precedent images can be really powerful, especially when the client has a specific, specific style that they want to reference, and that the architect has been trying to stick to. Showing them, what a really beautiful overhang could look like can be the game changer, and can be part of the architectural language.
Thank you. Jeffrey Roden, did I miss a question from you? I'm seeing that you're in here. Or is it Mary that you're referring to? I don't want to miss anybody.
No,
We've got
I
5
was
minutes
going
left.
back. No, I went back into chat and I found it. It's really, this is for Miguel. Are you or anybody from your firm going to be at BSC's summer camp?
Oh yeah, there's quite a few of us who will be there this year. I play music in the back house at summer camp in the little acoustic cafe
Cool.
house. So if you want to come listen to me, we usually will go like right after dinner around 7, and we'll play every song we know until 11 or so, and then we all just, everybody's had too much wine and is tired at that point, so we just forget how to play the guitar. But yeah, there's a few of us who play out back, and then from Positive Energy, I believe we're gonna have our 2 project managers, myself, Christoph, and then another one of our kind of consultants who's actually like employee number 1 with Positive Energy. He also has a great company here in Austin called IAQ Texas. They do like aero barrier, duct cleaning, that sort of thing. He'll be there as well, and he's just a great building science consultant generally. Does a lot of our forensic consulting when we get into that a few times a year. We have some fun forensics that we do.
Great. So in that case, expect to be cornered by me somewhere for a little discussion.
Let's chat, man.
Instead of this. So no, it's great. And for everybody, Boston, Building Science Corporation, it's their Building Science Symposium. It's the beginning of August. And if you like building science, there's not a better place in the world to be.
I heard that there's a new rule this year, Jeffrey.
Which is?
If you're not wearing a passive house accelerator, sir, you're left at the curb.
Well, fortunately, I have one.
Oh, you do.
Mark, I'll bring my fair share of t-shirts and we'll give them out there. Jeff, I'll see you there, and Miguel, I'll also see you there. I hope to enjoy the acoustic positive energy that's always at summer camp, and that's my last pun of the night. So
love it.
I wish I could join you all maybe next year. I was hoping to get there this year, but I'll be with you in spirit for sure.
We're gonna make sure Kate goes next year too.
Yeah, me too, Shannon.
All right, Kate, pinky swear. And if you guys want to throw your philosophy group link into the chat, I know I'm on that mailing list. I rarely make it, but I always try. And I just threw the podcast, Building Science Podcast, into the chat, which is amazing as well. And I've met many people through that podcast that I wouldn't have known otherwise.
Cool.
And so I appreciate that you do that. It's an excellent resource. Thank you so much for taking the time to share your work with us, to share your personalities with us, your mentors, and just your relationship, because you guys are really fun together. And I'm sure that working together is a blast. Keep up the good work, you guys.
Thanks so much for having us.